Hey everyone, and welcome to this Masterclass Explainer for the Round Rock ISD 5th grade Matter Unit. Think of this as your high-yield prep period, literally packed into a box. Look, I know you're incredibly busy, so we're going to jump right in and walk through the exact materials, the core concepts, and the teaching strategies you need to tackle this unit with total confidence. By the time we're done, you'll be completely ready to bring these science concepts to life for your kids. So, here's our roadmap for the unit. We'll cover 1. Unit Teaks and Mastery. 2. Core Science Concepts. 3. Common Student Misconceptions. 4. Investigations and Modifications. And finally, 5. Vocabulary and the Interactive Word Wall. All right, let's kick things off with Section 1, Unit Teaks and Mastery. This entire unit is driven by Teaks 5.6a. In plain, everyday language, this standard just means your students need to compare and contrast matter based on its physical properties, things they can measure, test, or observe. We're talking about mass, magnetism, relative density, and remember, that's specifically sinking and floating using water as a baseline. We're also looking at physical state, volume, solubility in water, and a material's ability to conduct or insulate both thermal and electrical energy. So what does mastery of Teaks 5.6a actually look like by the end of this unit? Well, it means your 5th graders aren't just memorizing random facts. Instead, they're out there independently analyzing their own investigation data. They can compare and contrast materials based on properties like mass and solubility, and honestly, most importantly, they can construct solid scientific claims supported by the CER framework, claim, evidence, and reasoning. Basically, they need to be able to back up exactly what they say using the data they actually collect. Moving right along to Section 2, Core Science Concepts. Okay, so the absolute most crucial point to grasp right out of the gate is the distinction between mass and relative density. Mass is simply the amount of material inside an object, just how much stuff is there. Relative density, at least in the context of 5th grade, is strictly about an object's ability to sink or float when compared to water. That's it. Massive objects can easily float, and objects with very little mass can sink like a stone. It is all about density, not just the weight or the amount of material. You're also going to need to confidently explain conductors and insulators to your class. And whether we're talking about thermal energy or electrical energy, the rule is exactly the same. Conductors allow that energy to easily pass right through them. Insulators, on the other hand, have the exact opposite job. They are materials specifically designed to reduce or completely stop the flow of that energy. Now, to really hit this Teaks standard, your students absolutely have to get comfortable with specific scientific tools. Notice the pairings on this table. They'll measure mass using a pan balance or a digital scale. They'll find volume using a graduated cylinder. They'll test magnetism with magnets, and they'll measure thermal energy transfer using thermometers. Honestly, getting your students comfortable with these specific tools is half the battle in mastering the standard. All right, Section 3, Common Student Misconceptions. We've all had students who are fully convinced that heavy means it sinks and light means it floats. It's totally natural for them to think that, right? But you must explicitly teach them that mass or weight does not determine sinking. I mean, think about it. A tiny pebble sinks right to the bottom, while a massive, heavy ocean liner floats perfectly fine. You really have to continually reinforce that relative density is the true property that decides whether an object sinks or floats in water. Here's another major hurdle you'll run into. Students constantly confuse melting with dissolving. When you get to those solubility labs, really emphasize that dissolving means a substance, like sugar or salt, breaks into tiny microscopic particles that mix completely with water. They mix so well that we can't even see them anymore. Melting, on the other hand, is entirely different. It's a change in physical state, going from a solid to a liquid, and it's caused strictly by adding heat. You'll also need to bust the myth that all metals are magnetic. Kids love to generalize this one, but your hands-on labs using everyday items like aluminum foil or copper pennies will quickly disprove it. This hands-on evidence is exactly what helps them understand that only certain metals have magnetic properties, while plenty of others are completely non-magnetic. Moving on to Section 4, Investigations and Modifications. Let's talk about the labs. So your flagship lab to kick off this unit is called Lots of Liquids. And let me tell you, this is a fantastic investigation. Students get hands-on experience measuring mass, volume, and relative density all at the exact same time. Though I will say, definitely brace yourself for the controlled chaos of handing 5th graders water, oil, and syrup.
The procedure here is simple but really powerful for the kids. First, they measure out equal volumes, 50 milliliters, of water, corn syrup, and vegetable oil. Second, they measure and record the mass of each liquid using a balance. Just remind them to subtract the mass of the empty cup. Finally, they gently layer those liquids into a graduated cylinder. And this is the aha moment. They'll discover that even though the volumes are completely identical, the masses are very different. That heavier corn syrup sinks right to the bottom. The water sits perfectly in the middle, and the lighter vegetable oil just floats right on top.
Now, what's really amazing about this setup is how well it supports a diverse classroom. If you have emergent bilingual students, or honestly anyone who just needs a bit of language support, you have these excellent modifications built right in. Notice the categorized sentence stems provided, giving them frames like "the blank sank because it is denser than," or simply "I see 3 layers in the cup," provides the exact language framework they need to actively and confidently participate in your scientific discussions. A bit later in the unit, you'll run the Thermal Insulators Lab. For this one, students wrap cups with newspaper, aluminum foil, and foam, and they leave one cup completely empty as a control. Then they add ice, wait 20 minutes, and measure the melted water. Now here is a really critical tip for you as the teacher. You have to explicitly emphasize that finding more melted water in the cup means that specific wrapping material was a better conductor. The cup with the least amount of melted water, that one shows the best insulator. It's a little counterintuitive for them at first, so keep driving that point home.
And throughout all of these labs, I highly recommend relying on these leveled emergent bilingual modifications. For your beginners, use total physical response. Basically use hand gestures to act out sinking and floating. For intermediate learners, provide sentence stems that compare the materials. And for your advanced EBs, require complete sentences using comparative and superlative adverbs, something like "heat moves the fastest through aluminum foil." Doing this ensures that absolutely all of your students are actively practicing the comparative language that is strictly required by the TEKS.
Okay, on to our final section. Section 5, Vocabulary and the Interactive Word Wall. Here is the core academic vocabulary you'll be focusing on for the unit. We're talking terms like mass, volume, relative density, conduct, insulate, and solubility. But remember, these aren't just spelling words for a Friday quiz. These are the highly specific academic terms your students absolutely must master so they can successfully articulate their claim, evidence, and reasoning. To help you teach this, the unit provides you with explicit, interactive word wall scripts. So here is exactly how you'll deliver it in class. For the word matter, you'll say, matter. Show realia, rock for solid, water bottle for liquid, inflated balloon for gas, TPR, solid equals stand rigid, liquid equals sway, gas equals spread out. Continuing that script for mass, you'll say mass. Word origin, massa, which is Latin, means lump. Show realia, balance scale, gram weights, cotton ball, rock. Next, for volume, you'll say volume. It has multiple meanings, but in science, it's space. TPR, large volume equals spread arms wide, small volume equals make yourself tiny. And finally, for relative density, you'll say relative density. Related words, sink and float, are antonyms. Show realia, water container, cork, coin, wood piece, paperclip. Having these exact scripts takes so much of the guesswork out of vocabulary prep. And with that, you are fully prepped to conquer this matter unit. You know the TEKS, you know the science, you've seen the common pitfalls, and you have the labs and exact vocabulary scripts ready to go. So, the question I'll leave you with today is this. With all these incredible tools right in your back pocket, how will you turn your classroom into a laboratory where students don't just learn about matter, but actively discover the invisible rules governing their physical world? Have a fantastic time teaching this unit, and we'll see you next time.